Hello and welcome to the fourth and final video in this series, FileMaker and Graph Databases. My name is Joris Aerts from ClickWorks. We are a FileMaker Platinum partner based in Antwerp, Belgium. Download these sample files from our website clickworks.eu, look for our blog. You can follow us on YouTube, Twitter, LinkedIn and so on. So welcome back. And this is the final video in a series of four. So in the first one I explained what is a graph, and I explained, for instance, how recommendation engines are very efficient in a graph, much more efficient than in a classic relational database management system like FileMaker is. In the second video we saw how to import FileMaker data in a graph with a personal database and what the advantages were, like for instance find float rings. In the third video we saw how to update the graph from FileMaker using API calls. And now in this video I'd like to show you how a graph can act as a backend for a FileMaker front-end database. So is it possible to get rid of FileMaker tables and to rely only on the graph? Now first, why would we want to do this? And based on the recommendation engine problem, I decided to try to find it out for myself. And remember the movies example and the recommendations for an actor like Tom Hanks in the first video. So I wanted to try that in FileMaker, and I built my first recommendation engine in FileMaker. So let us have a look. This is actually the entire internet movie database imported in FileMaker. So I have like 350,000 actors in here and a lot of movies. So I'm on Tom Hanks' record. I can look for whatever actor I want, like Sean Connery for instance, and look how amazing it is. But FileMaker's quick find does a very good job actually looking through all these actors. So I can look for Sean Connery, I could look for Scarlett Johansson, and then click on one of our movies. And as you can see, even with this large amount of data, FileMaker's indexes work just fine, and I can do this kind of searches very quickly. So FileMaker is doing a great job. Why would I need something else? Why would I need a graph database? Well, let's go back to our recommendation engine example, and let's go back to people, find Tom Hanks, there he is. Now if I click this button, I would launch the same type of search we saw in the first video. So I will show recommendations, actors who have not yet been playing with Tom Hanks, have not yet played with Tom Hanks, but his co-actors have. So who could I recommend as a new co-actor for Tom Hanks? Now before I'm going to click this button, I would like to show you how I did that in FileMaker. So I'm going to open up the relationships graph. And so I basically built this relationship. I have on the left hand side the actors table, and then in the cast table I can show all the movies this actor acted in. And if I go again to the same cast table based on the same movie, I can show all co-actors for Tom Hanks, and to find their person records I just need to go to the persons table again. So if I go once through this chain, starting with Tom Hanks, I will find all of his co-actors just by saying go to related records. So this works just fine, and then I will end up with a found set of person records with all Tom Hanks co-actors. Now then I can do it a second time, and using go to related again, I can go from Tom Hanks' co-actors to his outer ring, actors that his co-actors have been playing with. So Tom Hanks co-actors. And in FileMaker I can do that. Starting from a found set here on the left, I can say go to related record, match found set, to extend that found set with all the other related records. And this is how I would find Tom Hanks' outer ring. And then the hardest part will be to filter out people he has already been playing with. Okay. For that I created a little script that I'd like to show you. It's the find potential new coactors. So this statement is basically to find the starting node, in this case Tom Hanks, and there it really starts. So this is the first go-to related record to find Tom Hanks co-actors, and I'm using the list of summary field to put all the IDs of Tom Hanks co-actors in a variable so-called co-actors variable. Okay. Then I go through the same chain again using go to related records, but this time I'm saying much found set. So I will find all co-actors of Tom Hanks co-actors, the co-actors. And then I need to filter out those that already appear in this first inner circle direct co-actors. So if on the outer ring I find someone that's already on the inner ring, I just simply omit the record. And then I would end up with a list of recommendations for Tom Hanks. Note that they are not yet ranked by number of connections. That will bring us too far, because you can already imagine these kinds of queries will return a lot, tens of thousands of records, and it will take a fairly long time to process. So I'm now going to click this button to launch that script, and as you will see, this takes more than a couple of seconds. This will actually take like 1 or 1.5 minutes to find. So while FileMaker is doing that, I'm going back to our keynote. Okay, we're back. I just waited a couple of minutes for you, and my script has finished running. Look at this number of results. I find 80,000 potential co-actors for Tom Hanks, and because they're not even ranked by best matches, this list is pretty meaningless. But this just to show you that it takes a long time to do this kind of queries in FileMaker, because FileMaker needs to find primary keys and foreign keys in join tables, and it's inherently slow. It's not FileMaker's fault. It's just that a traditional relational database management system is not very well suited to do this kind of queries. Okay, so I wanted to unleash this power of graphs, like we saw how recommendations engines can be very efficient in a graph, and I wanted to integrate that in FileMaker. So let me close this database, and actually I have the same database, but this time powered by Neo4j. So there is no FileMaker backend anymore. Look, there are no FileMaker records, meaning that I cannot use FileMaker's built-in quick search. This is a so-called virtual table. So all these fields are actually fake. And what I'm doing is basically querying Neo4j all the time using the same API calls we saw in the previous video. Okay. So that means I have to script everything. I cannot use FileMaker's native search, so I have scripted a quick search here, and I can look for an actor. And this works because behind the scenes I have Neo4j running, and I already started this database, the movies database. It's not exactly the same movies database as I had in FileMaker before. It's a smaller subset that I could download from the Neo4j website, but it will do just fine. I have 63,000 nodes, whereas in FileMaker I had like a couple of 100,000 of nodes. Okay, but this one is up here. I already started it, so I just click the start button, and I'm now using it from within FileMaker, meaning that every keystroke in FileMaker is an API call to the database, and it brings me back the results. So I can now just click on Sean Connery, for instance, find this record, click on this movie, and each click I do is basically a request to Neo4j using the API. And look how fast this is. So to a FileMaker user, this seems like a perfectly normal FileMaker solution. Okay, it's very hard to see the difference between the previous database that was a native FileMaker database and this one where there are no FileMaker records at all. Okay, now let's go back to our Tom Hanks example, and I have exactly the same recommendations button here. So it took a couple of minutes to do that in FileMaker. If I now click this button, this will launch the same recommendation engine query in Neo4j as we saw in the first video of this series. And let me just click on it, and boom, within 1 second I see a list of, or better, a top 10 of recommendations, because this list is actually ranked by number of matching connections, matching relationships. So apparently there are 35 people who can introduce Tom Hanks to George Clooney. So 35 of Tom Hanks' co-actors have played with George Clooney, but Tom Hanks himself, he has not. So if I now click on this button, I can reveal the people that can introduce Tom Hanks to George Clooney. And there they are. Just going to zoom out a little bit, and on the one side we have George Clooney, on the other side there is Tom Hanks. The green dots are all the movies Tom has played in and the other movies George has played in, and these are the 35 people in the middle. So all these people can introduce the one actor to the other. I'm using a FileMaker web view with some JavaScript to create a graphical representation of these relationships. Okay, so this is entirely driven by the power of my Neo4j database. Now I wanted to show you one final example. There's actually a Flemish actor, an actor from my country, who is now becoming famous in Hollywood. His name is Matthias Schoenaerts. And I would like to find the shortest path between this famous actor Tom Hanks and our Flemish actor Matthias Schoenaerts. So I'm using one of the built-in functions from Neo4j, the shortest path function. It's a built-in function in Neo4j to find the shortest path between two very remote nodes, the famous actor Tom Hanks on one side and our fairly unknown Flemish actor on the other side. So if I click the shortest path, I immediately get back the different persons our actor should contact to get in touch with Tom Hanks. So I hope this gives you a glimpse of the power that is accessible by using graph databases, and we can tap into that power using API calls from FileMaker. So let me just summarize a little bit for you. FileMaker tables are not real tables, they just contain one record, or in the case of the cast table, it contains a fixed virtual list of 100 records. I do not expect more than 100 people on the cast list for a movie in this example. Quick search, the portal we saw in the quick search, also is a virtual list containing up to 100 records. All fields in my database are basically calculated fields derived from one global field. So I do an API call, I load the JSON I get from the API, so the JSON data from Neo4j in a global field called JSON. I do some pre-fetching of the data using this function, and then in the different calculated fields I use JSON get element to parse out the different elements like the name, biography, ID, and the URL towards the image of an actor in this case. Okay, so all these fields are calculated fields based on a JSON string using JSON get element to parse out. That means I can use the advantage of FileMaker UI building, creating layouts, and using fields on my layout as if it were FileMaker native fields. I can use portals, I can use popovers, I can run that on an iPad, on an iPhone, I can put that on FileMaker server, but the data engine is the Neo4j graph database engine, allowing for some very powerful searches and recommendations. Okay? That means that everything needs to be scripted. So the quick search is scripted both for movies and persons. If I click on a movie, I need to launch a script to do an API call. If I click on a person, I need to launch a script to do an API call. But these scripts are fairly similar. We already saw in the previous video how to create these kinds of interaction using insert from URL and JSON. So if you have not learned that yet, go to the Custom App Academy and watch videos about JSON and about insert from URL, because that is the future. This is how we connect FileMaker to other very powerful environments like Neo4j. Now these scripts are basically always the same. I put some kind of cipher query. For instance, this is the quick search query. I put that in a JSON string, put it in a variable, build a header, attach the data piece to the header and use insert from URL to the API endpoint of my Neo4j database. And then I start parsing out to returning JSON. And in this example, I use calculated fields to parse out JSON. I could as well have used scripts and set fields and so on. So this is an example of a quick search query. So finding person nodes where the name is similar to. Yes, there are some special symbols to do uppercase, lowercase, I think, and to mimic like contains pattern. This is a quick search text, and this is what I get back. I will get IDs and names, and I limit it to 100 since my virtual lists can contain up to 100 records. Now with this, I'd like to conclude this video. You can download the example file from our website, clickworks.eu, watch for the blog section. Of course, you can download the FileMaker sample files, but you would need to load a similar movie database set from the Neo4j website. Okay, thank you very much for watching this video, and I hope to get in touch with you soon. Bye-bye.